this should work.
Right. So.
All right, so I am not Simon O'Toole, and there have been a few little updates to the program, but we are keeping all the online stuff accurate. So if you do want to see any of this, any of the updates online, or in some case even get the slides, some of those are posted as well, so you'll be able to access all that. So I'm Elena Hyde, and I'm here to tell you guys about observing preparation and software tools. And there's a lot of overlapping themes in this workshop that sort of come up again and again. And thank you, Warwick, for the very good introduction, because I think it addressed a lot of those themes. You're going to hear words like archives and online resources a lot in this. And also asking other people for assistance, and how, you know, that's actually a really, really important part of most good observing proposals. So just before I get started, I'll just say, as a speaker, I don't mind if you post pictures of me online. I do have a Twitter account. Just, you know, if it's I'm doing something really weird with my face, maybe just don't post that one. But I think most, you know, speakers are okay. Just maybe check with them. Otherwise, you know, just if you want to post things about the slides, that's always okay. All the slides will be online afterwards. So, observing preparation and software tools. This is sort of a subset of interesting resources that I've used and that other people have used. And I'm not going to say that I'm by any means the expert in all of this, but there are experts for each of these things in this room. So if I can get this to work. No, I think we might be. No, I think I might be standing over here.
I was assured it worked.
You were lied to. So I'll just stand over here. Okay.
It was off.
That's not a lie. Okay, so whenever you're thinking about doing observing, you always want to have some kind of initial checks before you get started. And, you know, basic stuff like getting your science case really, really solid and being sure you know why this object is interesting to you. So whatever your favorite object is, it's subgroup B stars or supernova remnants or high mass objects, why is it important to observe, and what kind of thing do you need out of it to do your science? And that's a really different question than a lot of the technical details that you're going to need to actually write your proposal, but they're both really important. So do the calculations on your object, figure out what you really need to get out for the science, and then see what that means in terms of, you know, what magnitudes are you going to be happy with for your object, what kind of signal to noise is actually going to work for your science, what does signal to noise even mean in your case. So just have a good solid run through of the science, and there's really nothing wrong with diving back into your old equations and looking up, what does signal to noise even really mean? And some people just sort of, you know, grab the first definition they see, plunk it on, and don't think about really what their data is doing, and it can hurt you later. So I'm a big fan of lots and lots of preparation and doing a lot of reading before you actually get started. And one of the things you need to read up on is what's even available out there in the ether. All things are not available all the time, and some things are very, very limited. So keeping a good record of timelines, and how do you get those timelines, there's going to be a lot of links sort of throughout this talk, and also tomorrow, showing you where to find information, how to get updates, so that you know when things are coming available, and when, for example, you know, a surprise director's discretionary time has all of a sudden allowed your magic item to be, your object to be maybe requested. So it's you have to actually get into the news, follow the updates, follow people online. At ITSO, we actually have a news resource for you guys. It's an RSS feed. You can follow that. You can also get Twitter updates. A lot of telescopes post their observing updates actually online through different news feeds, and a lot of them are on Twitter. So Gemini, Keck, they actually have their own feeds online that you can follow, and Keck is a little bit different because they actually just post who's observing with what every night. And that's actually a really neat thing to follow along on, because you find out who's doing what with what instrument, and just getting yourself really familiar with all that information and knowing where to find it. So knowing what resources are available to you. Don't think that you have to, do this all yourself. There are a lot of people who are really interested in what the telescopes are doing. So just, make sure that you've got a good idea of how much time these things are going to take. And there's a rundown later on we'll do for Keck. It's kind of starting a year in advance is not actually a bad idea. Sort of like, if you're, those of you who are maybe applied for a PhD recently, starting a year in advance is really not a bad idea for this kind of preparation. There are things you need to do along the way. So of course, Warwick already mentioned the archives, and there's a talk coming up later, so I'm not going to dwell on this a lot, but it's free stuff, guys. So free stuff can be really, really good. It can also be a weird black box that you don't quite understand. So make sure you understand the archives and what's available. And if you're requesting a particular star from Keck with a set of instrument settings, you don't want to request something that's actually already been observed and is available through their archive. That just doesn't look good. They probably would not, think very kindly of that proposal. And you'll probably hear more about that when the KTAC talks come up. So free data, just keep that in mind, park it somewhere in your brain. And it can be really fun to just download, a few tens of gigabytes of stuff that's in an area that's interesting to you, a stripe of the Sloan survey or whatever you like, and just have a go looking at it. It's all there just to play with. Okay, so we also have lots of different telescopes. I have no chance to cover them all, but you're going to hear a few different rundowns of telescopes that are sort of commonly available. Actually, tomorrow, I'm giving a joint talk with Mika Brearley, so I'm not going to go through every single telescope right now, but make sure that when you're looking at different telescopes, you're checking the instruments and you're checking that your object's going to be visible from that telescope when you want to observe it, and that you're not applying for the wrong semester. So if they've got their semesters divided up into 2016 A and B, and you apply for the A semester and your object's not visible until the B semester, this can be embarrassing. So there's a lot to look out for and a lot to run through. And it's good to talk to other people about this. There are lots of people who are really interested in observing, probably with the same telescope you are, or maybe you have already done it and can help you out. There's no reason to do it all yourself when there's so many cool, interesting people to talk to about it. And if there's anything I can kind of impart to you guys all here, we're all interested in talking about this stuff. So if you have any questions about, I'm thinking about maybe applying for this and I didn't really know what I need to get it set up, pretty much everyone in this room is interested in that and can actually help you. So your basic step one, after you've done all this thinking and writing it out and deciding how you want to go, is going to be applying for time. So you have to be writing telescope proposals, and the TAC talk tomorrow by Rachel Webster is going to go into more of the nitty-gritty details, I think. So I'm not going to go into it a lot, but just know that this process is really, really key step in getting anything from your observations, because if you can't get your proposal accepted, you can't get the data. And what you need to do for that proposal is very different than what you need to do for your private science case, and what you're going to need to do when you're analyzing your data. You have to make sure you prepare it in the right way. So there's a bunch of resources available. This is a whole string of links that we have, and all of the International Telescope supported offices have their own pages. So I actually put that, yes, this works too. I've put our homepage up here, and we've got support for Magellan, Gemini, Keck, and Blanco and their archives. And so you can go on there and click on summary for the telescope and see what we have to say about applying for time, and then go to the actual telescope website, see what they have to say. So there's already quite a lot of ways you can try to get time. And the AAO lens system comes up when you're trying for things like Magellan or Blanco. Keck has its own KTAC process. And Gemini is a sort of a special case that we're going to be addressing along the way. But you can still try to get Gemini time. And there are resources to do that. We have information pages. You can read through it. You can see when the deadlines are opening and closing and all that good stuff. So just make sure that you know that these pages are all resources for you. And if you can't find something that you really, really need and you've looked around, ask us for it. If there's something in tech and you're like, oh, I really wish I could find this and I can't see it anywheres, that's something that I think we'd like to know about. So once you've read up on some general information, the instruments are the other thing that you're going to have to do a lot of reading on, because each instrument is a really different type of animal, really. And you've got a lot of different descriptions. You've got different signal to noise. You've got different types of pixel scales. Some of these instruments behave very, very differently. You could have multiple object imaging systems that actually work really differently from what you're used to. So it's really worthwhile doing a go to read on the web page. And if you don't understand something, there's nothing wrong with just popping an email to your instrument scientists. And a lot of times these guys will have their emails listed right on the page, and somewhere in tiny, tiny font at the bottom, they'll say, if you have any questions, please contact us. So do that, email these people, ask them if you don't understand something. And of course, the documentations and the manuals, if you've read through those, when you go to ask your question, it's going to sound a lot better than if you just sort of, ask without reading anything. It never looks good if you're sort of asking about infrared capabilities on a purely optical instrument or vice versa. And of course, using the signal to noise calculators, this is kind of a two-pronged thing. Finding good signal to noise calculators and using them and understanding what they're doing. So they don't all operate in the same way. Different people have written different codes. Make sure you know what you're getting out of these things. And of course, also your targets and what you need from your targets are going to be really different for different telescopes. So for Keck, for example, if you need to access the adaptive optics on Keck, this is a different process than if you're not accessing the adaptive optics. And Keck has the cool laser beams that shoot out of the domes, and you can make an artificial star. And I think there's now an ITSO telescope that has 4 laser beams, which is crazy. But the point is that this is a really different type of observation you need to plan for. And if you really need those adaptive optics, if you need to resolve, a close binary star that's not resolvable otherwise, then great. But if you don't need it, don't ask for it, because that's not going to look very good. For Gemini, for example, you might want to worry about, are there good guide stars available where I'm going, and what type of observing mode am I going to have to use. And the point is, every telescope has its little idiosyncrasies, and you have to look those up and find out what your targets mean for that telescope. For AAT and Magellan, you want to have good backup targets in science in case there's poor conditions. So if you're seeing all of a sudden gets kind of bad, what can you do? Do you have a backup plan? So what's your plan if the seeing is perfect? What's your plan if the seeing is, worse than what you wanted, or half, or a third, or whatever? So you've got some kind of idea of how you're going to proceed if you've just got that little window. Maybe there's a collaborator somewhere that would like to contribute some objects to your plan, and they want things that are with poor seeing, and you want things with good seeing. And so really pulling together these kind of things is very important. And again, it's also talking to people. Very, very important. Don't try to do it all by yourself, because this will hurt you. So every telescope is different. We've talked about this before, but it really is, if you have spent a lot of time trying to write a Gemini proposal, and you then say, okay, well, I didn't get it, but I want to take my proposal and I want to go over to Keck with it, because I think it would be good on Keck too. Do not just copy and paste. This is a really bad idea. You've got different seeing limits, different instruments, different light pollution amounts. Maybe on one of these telescopes there might be a radio tower somewhere off in the distance in the direction of your object that causes an interference pattern that you didn't know about. There's all kinds of things that can happen with different telescopes that you do want to think about. So don't just copy and paste your proposal into that telescope, even if it kind of looks the same. It's like, oh, this is a big telescope, but they're not. They really are, well, unless it's the twin of the other one. So in some cases they're Gemini, Magellan, Keck, they all have twin telescopes. So Keck 1, Keck 2, they have different instruments, but they're very similar telescopes. So that would be the kind of exception. So again, we have in here, really communicating with people, finding those interested people out there who want to help you with your observations. So speaking to your support astronomers, so the AAT has assigned support astronomers who you can email and correspond with and can help you prepare your observations. And Gemini and Keck, Magellan, Blanco, they all have different types of support avenues that you can access. And of course, you have ITSO support as well for those telescopes. So we offer support pages and different amounts of support for the different telescopes. But again, you will find quite a lot of this on our website. So I very much encourage everybody to have a read through that, and see if any of that's things you want before asking. Also, really, really helpful, other than staff and support staff and astronomers who are working at telescopes, previous users. So do you know anybody who's used this telescope before? Does your supervisor or does one of your colleagues have a friend who is up there? Knowing an observer who's gone up and who's done this can be so, so valuable, because a lot of times, a support astronomer or somebody who's sort of, at a professional level, who's maybe not been in as an observer, might not have the same point of view. And sometimes you get really, really great tips from people who are just observers and like, oh, by the way, did you know about this cool software that will do this entire set of calibrations for you that I downloaded from some website that you'd never find? So it can be really, really good to talk to people who've done it before. And if you can, or even if it's a colleague or somebody, I very much encourage you to email them and get in touch with these people. And I think you'll find that most people are enthusiastic about their observations. Like, I'm quite happy with all the observations I've made. If somebody asked me a question about that, I'd be really happy to tell them about my observations at the AAT and how that worked and what I had to watch out for and what I had to prepare for. And I think, most people would, but you don't think about it because you're like, oh, well, it's not their observations, they won't care. But actually people do. So I'm a big fan of trying to contact people, and I wouldn't say that I'm great at it, but it's something I think is beneficial to us all. So in addition to people contact and people leading you to valuable tips, there's lots and lots and lots of software tools to complement support. And again, this is where you have every telescope is different, every instrument is different, and the support tools and the software tools that you're going to want will be different for those instruments as well. So in terms of signal to noise calculators, the Gemini and the AAT have them. Magellan, I think, has something available, and Keck has a few specific ones for different instruments. Gemini also has an integration time calculator, which is something that I've been playing with recently. But know where these things come from, because, like I said, they're not all equivalent. So once you've got your sort of basic setup and you've done a bit of research, you're going to want to check your objects for the telescope you have. You want object visibility. You want to make sure you're not running across the moon or the horizon or anything else you don't want, bright planets. So you want to make sure your object is good for this telescope, that you've got it at a high air mass and all these cool things. So there's a bunch of different software online. This is not a comprehensive list, but it's sort of a few of the most popular ones. So StarAlt, the IAC, this site, ING-IAC, StarAlt, StarObs, they basically standard, it's completely free. You just hop on your website, and most telescopes are in there. There are some that aren't, but I think I've not found any recently that I couldn't get on there. There's also a Pythonic version that does a very similar thing called Astroplan. So if you're really into Python, and you know, I'm one of those people who thinks everyone should be. It's got some amazing capabilities. The Astroplan might be good. There's also a few alternate ones. One that I thought was kind of strange is there's somebody actually made a iMac, iPhone app that you can get from the App Store, but it's not free, so that's why it's at the bottom of the list.
You actually check that for accuracy in that.
The app. Oh, I don't have it because it's not free.
The demo version is all right.
The demo version.
developed by a professional astronomer.
Yeah, it's a professional version, and I've heard really good things about it. Actually, it has quite nice reviews. The free demo does seem to work, but like I said, I don't have it because it's not free. So once the demo ran out, I just went back to using the. I actually used the top one. I've not gotten quite as far with Python as I want to. Yeah.
Can I just sorry?
No, after you.
In terms of talking about the Python things, I'm recently into the Python thing as well, and I was trying to do a Julian day calculator, Julian day.
Oh,
So
yeah.
I was using that, so I had to use an online calculator, and which was great, and that sort of worked with IRAF, the actual
So you
results
use
tally.
PyRaf or
IRAF, yeah.
IRAF or PyRaf?
IRAF.
Because
IRAF.
yeah.
But this is the point I'm coming to, I guess. And those two, using IRAF,
Yeah.
standard STD-JD,
Yeah.
I think is the thing. Anyway, those two happen to work. But the actual Python script that allegedly came with a calculator, which I put in my Python script, came out with something different. And it was like, well, written by a professional astronomer, that was the thing. So not all.
Well, that's, I mean, you do have to watch out a little bit with Python. I mean, there is so much available, right?
Yeah.
And a lot of it is developed by people in their free time. So you don't always know 100% what you're getting, so test it, right?
Absolutely.
And testing it against IRAF is actually a great thing to do.
Right.
Because there are several very different routines that you can download. And I'm not going to go into them all because there's other people who are going to be talking about Python a lot more. But yeah, you do need to be a little careful because unless you're willing to actually go into the code that you've downloaded and have a read through and see what the routines are doing, don't treat it like a black box because you don't necessarily know what they've included. So maybe somewhere in line 58 or something, there's something about resetting your telescope location to some place that's not where you want. So watch out for that. So I mean, in that sense, IRAF. I actually go back and use IRAF for a lot of this stuff as well. It's very simple, and the routines have, for the most part, good help pages, and you can see what they're doing. But you do get some errors associated with any calculation.
Right, but even with the IRAF, I noted. Spent weeks on this. I noted that even with IRAF, the previous version of this, or STD-JD, there is a difference coming out of there. So they've actually played with it as well. So I was looking at somebody else's paper to try and replicate it, and couldn't. And that was the whole thing.
Well, you have to keep in mind what catalog you're using as well. I mean, if something's not set to the right, if it's J1980 and not J2000. So just be careful with it. That's a good point. Don't treat all software as equal. And if you are going to use something, know where it comes from. So the Astroplan and the IMG site, they both have a lot of documentation available, so you can really dive into it. If it's doing something you don't expect, you should be able to find out why. And if the software you're using, you can't find out why it's doing something that you don't like, then that's probably not good software. So just, yeah, watch out, especially if you are new to Python. There's so much duplication as well. So I've seen several different programs for that. So yeah, good point. All right, so yes, very important code. And actually, I'm going to come back to it again as well, because it's just having those tools that just work well and reproducibly is very, very valuable. So again, once you're getting your observations ready, you do also have to make sure that if you're doing standard stars, you know where to go to get them. So each telescope, of course, is different. They all have their standards sort of listed for them and what that means. So this is just a little example. Keck's got flux standards. ITSO has a whole list of spectrophotometric standards that you can just grab, and there's Euclid infrared standards, Gemini, and there's always, once you found your telescope and your instrument, then go and look and see, has somebody done standards. And actually, if you can't find a good reference site for standard stars, sometimes you can actually go into the archives and find one that somebody's just observed and not listed as a special standard, and then you can just request that observation. Voila, you'll have a standard. And that can be a really, really valuable way of grabbing somewhere you wouldn't ordinarily be able to get them. So another really valuable thing to be able to get is integration time calculators. The AAT has a signal-to-noise calculator. Gemini actually has an integration time calculator. And Magellan, I believe they've got a sort of a spreadsheet that you can use. These are not all equal, and integration time calculators are, they can actually cause a lot of problems like the one that were just described with reproducibility. So doing a little bit of research into what your integration time calculator is and how it's working can help you a lot. And sometimes, actually, you might decide that you don't want to use the official integration time calculator. You want to actually use something that you wrote yourself or that you got from a supervisor. So, speaking of, Keck actually has several for different instruments. So on Keck, we've got Mossfire, High-Res, L-Res, and Iris. It's depending on how you write the L, it either looks like L-Res or Iris. But they all have integration time calculators associated with them, and it's all worth sort of looking at. For Blanco, DECCAM, maybe this was the one that was the spreadsheet. I was looking them up earlier, and yeah, this one actually is an actual spreadsheet, and you can back out an integration time calculation from it. So they're not all equal, and sometimes you really have to shop around. And it's okay to have an integration time calculator where you've used it and there's some limits to what you're able to estimate. And once you have that in your proposal, that's fine. Just make sure you say that I've used this because I think it's reasonable and these are the limits of this estimate. So again, going back to our conversation before, is software, very important. Are you going to need to do quick reductions at the telescope as you go along? Is what you're observing something that you expect to change on a short time base? Are you looking for some sort of oscillations in stellar brightness, or are you just gonna do the whole observation, not look at any of the data until you get back? And if you're going to do some sort of quick reductions on the site, then you need to know what computers are available, how you're going to process the data, all that stuff. And of course, aside from your own science goals and whatever quick reductions you might want, your telescope might require you to run certain software to do its observations. I think a good example is the AAT configure software. So if you go observing at the AAT and you want to use a Omega or Hermes, and you want to configure this beautiful robot and point at 300 and something different stars, you can show up with your list of objects and just hope that configure works. but you really should download this program beforehand, run your list of objects through it, and get configure working before you go up to the telescope. And some telescopes have software like that, where it's, if you're not ready and you waste an hour trying to get that program working correctly, rather than taking data, that's a sad night for, especially if it's all clear. Make sure it's all working in advance, and you can test a lot of things in advance. So especially if I continue with my example from the AAT, you can actually have your whole night's observing all planned up, ready to go with all the configure files, everything all ready before you even show up at the telescope. And you'll have to, change it on the fly if observing conditions change, but at least you'll have the whole program all set up. So it can be very advantageous. Actually, one other thing I didn't put on there in terms of pre-preparation is making sure you also check the calibrations you're going to need. If you are one of those people who has planned something that does actually need a large number of calibration files from the telescope, so flat fields or dome flats or cloud flats and this type of thing, that's all something you want to budget well in advance. So the AAT, we've got a few different resources available for. The AAO website has quite a lot on there, so it's sort of in a privileged spot. Yeah.
First name doesn't exist.
The first what?
First name doesn't exist.
Oh, I might have to update that. That's a good point. All right, I will check that. I have checked most of the links, but not 100% of them. Yesterday night I found out I was doing this, so it is on the AAO website. So if you just go to this first part, aao.gov.au, and do AAT signal to noise calculator, it should pop up. So I think the path has just changed. I think it's not /astro anymore. So I just want to run through a couple examples for a few telescopes. There's no way that I could ever give you all the links for all the different telescopes, and I think that would be a terrible talk. So so we'll just do the AAT and a few other ones. And A Omega configuring for 2DF, there's special links for that. Keck has a lot of tools available. So if you hop onto the Keck website, they've got web pages for instrument manuals. They've got overviews for the telescope. They've got telescope limit charts that show you sort of when you can observe your object. So you could check your whatever you've used, Pythonic or otherwise, to calculate your positions. You could check it with this. You've got ephemeris lists, and of course a laser guide star adaptive optics page for those of you who really do need to use adaptive optics on your observing. And you've got sort of a list of suggestions, so things they ask you to prepare for. And the thing I liked about the Keck rundown is that they actually give you a list of sort of a timeline to give you an idea of how and when to start applying for different things. So you get star lists. They're going to ask you for different types of star lists depending on what instrument you're using at different times. You've got an AO guide star tool, which you'll need if you're using the AO, and a finding chart tool, because of course the field of view is going to be different than whatever you used for your data selection. So if you've got 2-mass photometry, you put it into Vizier or some visualization tool, and then you're like, okay, well that little tiny bit is going to go through Keck. You might need some overlay tools. And of course they've got a planning tool for checking availability. And Keck also has something called split night considerations. So it seems to me, someone who's not yet gotten time on Keck, I will say, so there's a little addendum, that there's more split nights on Keck. And they seem to have a lot more of that available. So just keep in mind that if you are splitting the night with somebody, you really want to plan with that person. So if you get half a night or even a quarter of a night, and there's other people on before you, making sure it's all coordinated really, really helps you, because then you don't have, 30 minutes or an hour missed while you're transferring. So again, people to contact if you need help. This is a really big one. So Keck actually has a whole list. So in addition to contacting ITSO, there's a whole list of people you can contact for Keck as well. And again, guide stars and split nights or whatever you're trying to consider, this link definitely works. Will take you definitely to the planning instructions. So they've got a whole set of what they expect you to do. So they have 8 weeks before, and it sort of counts down from that. So 8 weeks, if you get it, 8 weeks before you actually go up, they're going to ask you for slit mask designs in the case that you need more than 200 slits. And 4 weeks before, you're asked for files and coordination. So you have to have prepared this well in advance, otherwise you're going to get some nasty surprises. And of course, don't forget to request a room so you'll have somewhere to stay. And 4 days before, you have to get your star lists up there. And they actually have something on as well where they ask to have sort of a meeting with the observers to run through what you want to do. And in terms of getting familiar with the instrument and the observations, one thing that's really, really nice, especially if it's a telescope that you're not familiar with, you haven't observed this before, contact whoever is on before you and ask them, hey, would it be all right if I just hung around for the night before or the 2 nights before to watch how it goes during your run, so that when you come up, you've already learned some of the weird tricks and tips, and if the telescope falls over, you don't completely panic. You know how to get going again. So Gemini has a lot of tools as well. Again, we can't possibly go through every potential iteration, but you've got integration time calculators for each instrument, and special tools for mask making. I think I'll be out of time. And Gemini South actually has a special case where if you're looking for photometric standard star fields, you would be really, really sad unless you had realized that this is a little project that ITSO has done for you guys. It was in conjunction with, Stuart, help me out.
Macquarie University PACE
Yes,
program.
Macquarie University PACE. And that's actually, we've tested the whole page, so all of the photometric standard star fields are up there and can be clicked and searched, and you guys don't have to do that yourself. So
the whole sky, is that?
Southern Hemisphere? Gemini South.
Just the southern sky.
So it's Gemini South GMOS.
Right.
So that instrument in particular.
Yeah.
This is just a screenshot from Gemini Pit. So Gemini has a lot of different tools available to you. And for the sake of time, I'm just going to show you a few. And these are things that you can access. So you can go to the website, you can try to get the stuff working, maybe even have a go with some archive data if you've got time to prepare it. And you've got an observing tool, so you can start planning now if it's for next year. Now is not a bad time to start. And of course, this is a couple more tools. So I'm going to try to finish up a little quickly, so we have give Andy a good amount of time. But it's very, very important to talk to your support astronomers. In this particular example, I think the support astronomer really is the Superman, because your support astronomer, in a lot of cases, this is somebody who has been at the telescope for many, many years and who has seen all sorts of things fail and knows how it runs. And knowing how something's going to respond under different types of observations, and just chatting with them and being like, hey, so this was my plan, what do you think about this? Can I run an idea past you? Do you think I could get away with squeaking in an extra observation of this object here and then going back to this field? And talking to this person before you just show up, right? So if you show up and it's time to start observing, of course your support astronomer would be like, okay, where do I go? Where do I point to? But getting some extra information from them about the telescope and the instrument and what's been going on with it. Something was just refurbished, or replaced, that can be really valuable to know. If a filter just got replaced and you were going to use that filter, you're now using a new version of that filter, and old comparison observations might have some slight differences. So this is all really, really good stuff to know. So I'll end there and say thank you, everybody. We're all astronomers, so wish you all lots and lots of luck, and hope you get data from all the telescopes.
Lots of sound advice. So, any questions? Questions for Elena? Yes.
So, this is a good talk. So I was thinking, like, because Australia has now a lot of facilities and then there's a lot of users who use it. Is it possible to have something like a repository or some like GitHub thing that people can post like small snippets they're waiting to? Because as you said, you can always talk to people and there might be users at the same time. But if you have something like
for code, you mean?
Sorry?
For code?
Yes, so people can put up like say okay, for Gemini Gmod just like I have developed something more.
Yeah, well, the Gemini did have sort of a community forum. It does have a community forum. I'm not aware of a community forum for Keck.
Oh no, I'm talking about for the Australia
But for Australia, I think that there's some information hosted on individual websites. So like the AAO has a lot of the information for the AAT. But if you are interested in the ANU 2.3 meter, for example, you're usually required to have an ANU PI, right? And so it's a little bit more difficult. There's not a good hosting spot that I've seen, sort of like, Stack Exchange, right? Yeah. So what you want is Australia Astronomy Stack Exchange. However, that said, you can actually find a lot on just Stack Exchange from things people have written. But yeah, that's a good point. I'm not aware of a really good. Gemini has a forum, but Australia, the AAT, all the really good tips I've gotten from AAT observations have been from people who I know who's observed there, or off of the AAO website, so the AAO AAT website.
Yeah, so Gemini tried this as a way to kind of spread their support in a way, and I think Kathleen probably more up to date, but it's hard to engage people actually. That's quite large.
Yeah, there's currently an effort going on that will enlist some contributors. So some people in the partnership will be asked to provide additional information and be moderators and answer questions. There's a big push this year to make it a bit more alive.
Yeah, you need a lot of
through this, we actually looked at other observatories' forums, and wasn't too good. It seems like astronomers are not willing to engage in such things. So we're giving it the last try to engage people.
Yeah.
We'll see what happens.
Well, it is hard too, because I think you get a lot more code engagement on things like Stack Exchange, and then people just sort of forget that the telescopes are there as well. So I actually have seen some telescopes codes on Stack Exchange, and GitHub actually. GitHub has a lot as well. But yeah, not on so much on the. You really need a dedicated person or office behind that endeavor, I think. It's quite difficult to get the right amount of engagement otherwise. That's it. If you'd like to post anything, I'm sure we can find somebody at the AAO to talk to and all that.
There's a good question about how to get help in a general context. Gemini has a help desk, which has a quite structured approach to getting input. For other facilities, it's sometimes less clear how to get access to help desks. Contact with an expert.
Well, that's why we've got, the ITSO office. We are trying to offer extra help for those facilities. But yeah, there's a lot that we can't provide, unfortunately. So yeah, That said, like again, ask anyone in this room if you do have a specific question, because we're all really interested. So.
Discussion. Any other questions on this topic while Andy gets set up?
Just suggest, clearly there probably won't be a lot of people who are likely to start using Gemini as a tool to prepare Gemini programs. But I would suggest to people it's actually quite a very useful way of planning an observation, even other telescopes, because the accessibility, you can use an image browser that allows you to download a digitized sky survey, in this case overlay sort of footprint of Gemini instruments, but let's face it, most of the other ones are not that dissimilar. They can do SL plot, altitude plots and things for you. So there's a lot of functionality there that is not exclusive to Gemini, and for those that are used to observing there, it's probably something many of us will continue to use because of the functionality it enables us to pre-plan observations and look at what the field's going to be like, try and identify suitable guide stars and so forth. So I wouldn't discount it just because you don't specifically plan to use Gemini. I think it's a relatively good generic tool that makes use of a bunch of Java code for querying various databases and image servers and so forth.
Yeah, that's a really good point, because sometimes you'll find that the best tool for your observations doesn't come from the telescope you want to use. So this definitely worth noting. Thanks for